In the previous tutorial video, we discussed how we can develop two acceptance test cases. Let's just review how they were meant for. So we develop AT01 and AT02, and remember AT01 is about how you can perform deposit, and AT02 is about what kind of error messages you have to produce when you got duplicate new account. Okay, and then we try to develop our program such that they will produce certain outputs for these two acceptance test cases, and then review them manually. Okay, so we actually review them manually, and then we were convinced that these two outputs should be the way it is. So that's why we promote them into expected. Okay, so now from there we actually say AT actual.txt should be what's expected, and also AT02 actual should be what's expected for the second case, right? So these are the two expectation that we actually have developed from the previous tutorial video. Okay, let me just say expectation over here. This kind of process is actually very normal because when you actually had no hints about what the customer really wants from the requirements, you have to really produce different scenarios in which you want to test to see what the reaction is from your program, and then you have to review what your program produced and then try to see if they make sense. If they do make sense, and then you will add them into your regression test repository and then call them expected. That's the convention we said we will follow. Okay, that's from the previous tutorial video. So now in the current one, we're going to introduce you to two more scenarios that's also going to happen very often in your lab and your projects when you're developing ETF projects. Let me just preview what's going to happen for the rest of the tutorial, and then we'll go ahead and try the two new scenarios, and you can follow along. So the first scenario is you might be just given a particular new test case. So this is completely given to you. And you are also given, for that particular input scenario, AT03, what the expected outcome should be. So this is also given. So this might be given by your customer or by your instructor or by whoever is going to review your work later. So these are simply just given. Okay, so you're given pairs of files. It can be AT03, AT04, AT05, and etc. And for each input test case, you have a corresponding expected file given to you. Okay, that's scenario number one. Okay, so this is scenario number one that we're going to talk about in just a moment. Okay, scenario number two is actually the most crucial one you want to really get used to, and especially when you actually maybe you decide to work from home remotely, and you have to make sure this whole process can run seamlessly with your lab computer. Okay, I'll show you. So scenario number two goes like this. Instead of be given the chance to consult with your customers in person, you will be given something called an Oracle program, and which is an executable. And the one we're going to give to you for this particular tutorial, we assume the Oracle is not directly executable on your home machine, assuming that your home machine might be either Windows or Mac or something that's not Linux. And for your Prism lab machine, that's the only place where you can execute this particular Oracle program. You can think about this Oracle program represents your customer. And then what you have to do in this case, given the Oracle program, you have to come up with as many input scenarios as you can. So you have to come up with AT04, AT05, and all the way through. And then every time when you're done with a particular input test case, you have to wonder yourself, what should be the expected outcome from my customer? In that case, you have to run the Oracle program directly on your input file. And then whatever that can produce, it will be considered as the expected outcome. That's why this program here is called Oracle. And conceptually, you want to make sure this Oracle program and your program, for example, the bank project we have been developing, these two programs conceptually must be equivalent. But how can we show for equivalence? The best way we can do is to say, for this many input test cases, maybe from AT04 all the way to AT1000, for all these test cases I can think of, the output behavior of the output produced by my program and the output produced by the Oracle program are completely identical. So that's the way we're going to follow. Okay, so we got two scenarios here, scenario number 1 and scenario number 2. That's kind of the roadmap for this current tutorial video. Let me do for scenario number 1. We don't talk about Oracle given to you just yet. Let's say you are given a particular pair of input file and also its expected outcome. Let's start with that, simple. And then let's review the development process very quickly, and then we'll see how you can do scenario number 2. And remember from the previous tutorial video, we store our ETF folder on the desktop or maybe somewhere in your 3311 workspace. And if you open it, you can see that under the tests folder, you actually got the instructor's test cases. Well, basically the 2 test cases we developed. Let's say AT01 and also AT02. So now let's go into this particular test folder. For now, let's assume we are simply just given another pair of test cases. Okay, so I will simply just copy and paste from my computer, and you can simply type them out. They're very short. Okay, so now I'll simply assume now I'm given AT03 and AT03.expected.txt. Okay, so AT03 itself is very simple. Okay, if you want to save some typing, you can simply copy and paste AT01. It's kind of like an extension to AT01. So up to here, we simply got new ID, new ID2. We got 2 accounts, and also we deposited 234 into ID1. And now in the new scenario for AT03, we simply try to withdraw $50 from the same account. Of course, you can do some similar derivation to actually try to come up with different test cases. But let's say this is some input scenario you're forced to actually consider. Okay, that's AT03, and now in this case, you don't really have to run your program on this just yet in order to decide what should be the expected outcome. Now the expected outcome is given to you. Now let's take a look at AT03.expected.txt. Of course, you can type it out. It's very easy to type. And again, it's very similar to AT01.expected.txt. So up to here, we have created 2 accounts and also deposited 234 into the first account, ID1. So now what we're doing is we're trying to say withdraw ID1 50, right? The expected outcome, not surprisingly, should say it should be 184. Okay, so now the question is our program, is our current program's produced output going to match this particular expected output? We would think maybe no, because we have not done the withdraw feature just yet. Okay, let's confirm this. So what I will do is I'll go to terminal over here. So I'll go into my ETF folder and bank. Okay, and then I already got my project compiled, so I can just execute the batch mode from the command line. Let me do that quickly. So I can say ifgens and then bank wcode and then bank and then -b, right? So for those of you who are using Windows, when you actually run the batch mode, the output may not be so easily can be captured. So we're going to show you something that's going to work better by assuming that you may have a network connection. But we'll do that when we consider scenario number 2. So now I'll say -b, and then I'll go into the tests folder. Acceptance instructor AT03.txt, and we want to generate the actual file to see what your program actually produces into the same folder. So let me write it again. So you say tests acceptance instructor AT03.actual.txt. Okay, and then let's see what it produces. And it shouldn't match the expected outcome because we haven't done anything yet for the withdrawal. Let me go back here. So now you will see AT03.actual.txt. Okay, so now if you look at that, you can see this guy here, you can see it remained to be 234. So this is actually what the program is actually producing right now, and that does not match the expected outcome. Let me just show you again how you can see the discrepancy. Every time you see any discrepancy between the actual output and the expected output, that means you are not meeting the expectation just yet. So that means you are not really doing well. Last time, in the previous tutorial video, I showed you using diff. If you're using either Mac, Windows, or Linux, there's a program that's also very useful called Melt. Okay, I'll show you how you can run it. you can simply, let me just go to the test folder, that's easier. I can go into tests, acceptance, instructor over here, right? I got all the acceptance test cases over here. Now I want to compare the actual versus expected for AT03. So I would say melt AT03 dot actual dot txt and AT03 dot expected dot txt, right? I just want to compare them. Okay, I can run in the background. And now we're going to see whether they are the same or not. And the melt program is very useful because now it has some nice GUI interface. And now you can see they are not really the same. Especially you can see for this particular line. So this is the actual output from your program currently. And this line here is from actually the expected output that was given to you. And you can see this guy here is 184 versus 234. Okay, they are not matching. So we are convinced our program is not good enough as far as the expected outcome is concerned. Okay, I'll exit from here. And now you also can start using the melt program. So now I will go back to where we were, and then we'll try to go back to our Eiffel Studio and try to program our withdrawal. Okay, I'll do that very quickly for you. You can also follow along, and there will be some exercise for you later. Okay, so now I will simply go back to Eiffel Studio, and then I will go to the model cluster, and then what should I change? Basically, in the account or in the previous work, we already developed deposit over here for a particular account. Why don't we do something very similar for for withdrawal? So what I will just do, I will just copy that, and then I can say withdraw. And then you should be balance minus the amount, okay? And then of course you should really try to compile for every few changes you make rather than waiting until the end. Okay, it's really important to make sure your code always compiles. And then I will go back to the bank over here. And then once I do that, and then I will go to the bank, you can see currently the withdrawal feature is over here without any signature, without any parameters. It is because we simply did something by default. And if you recall, in the relevant ETF command class, if I go to ETF withdraw, you can see that there is simply just calling this default withdrawal, which does nothing useful. So what I would do is I should change both places, of course. So I'll go to the withdraw, and then I can simply just, let me just copy the signature here. Okay. And then I'll go back to the bank, and then I'll paste it. Okay. So we'll have a string ID and also the amount to withdraw. And then let me also comment this out, and then we can simply just use what we did before for the deposit. Okay, just copy and paste. And we can do that. Okay, and then we can say across the accounts, and then if the ID matches, we're gonna withdraw. And of course, as soon as we hit compile right now, it's not going to compile, simply because if you read the error messages, round number of actual arguments in feature call. If you look at that over here, we're calling a withdrawal feature without any input arguments. However, we just changed withdrawal method, the withdrawal feature here to have two parameters, right? It's a mismatch. Easy to fix. We simply go back to ETF command, and then ETF withdraw class, and then we'll say ID here and then amount here. Okay, that everything should compile right now. Okay, so now we believe this new extension to our program should really be able to satisfy the new expectation as specified in AT03. Okay, let's see. So what I can do now is, remember this melt command I ran previously. Okay, what I can do is I can simply just run it. Again, so now it will show me that there's one thing I forgot. I forgot to actually update the actual file. Okay, that's some tip for you. Actually, you don't want to forget to actually update the actual file. However, you can see this kind of process is kind of very tedious. Every time you make a new change to your program, you have to generate this actual file manually before you can compare that against the expected file. In this case, I forgot to actually rerun my program to generate a new actual file. So that's why I'm still seeing 234. Maybe my program is correct right now. So that tells us as we'll see in the second, as we'll see later, it will be very useful if we can automate this entire process, and we'll see how we can run regression testing automatically later. Okay, just remember this lesson here. Okay, I'll exit from here. What I should do now is I should regenerate that particular actual file. Okay, that's what I will do. Okay, but now I'm actually in a different folder. So what I will do is, okay, let me do that quickly. Because now I'm now in the tests folder. So what I will do is I'm going to ifgens bank wcode and also bank batch mode, and then ato3.txt and ato3.actual.txt. So this will be the new version, right? Of course, I can redirect it over here. Okay, so now the actual file is now updated. And if I now run the meld again, let's go back to the command over here with a meld, comparing the actual versus the expected. Let's see what's going to happen. Okay, let's run in the background and over here, and it should show the two files are identical. Okay, you can see now from the meld, you simply say the files are identical. Of course, if you really don't really have meld working on your machine, you can definitely still use the diff. That's definitely available too, or any file comparison file program. Actual.txt, ato3.expected.txt. Okay, so now basically it will simply say there's no difference between the two files. So now what we have achieved was like this. What we have achieved basically is given ato3 a new input scenario to consider with the withdrawal, and also the corresponding expected outcome file. So these two were simply given to us as a new scenario. What we did was we simply tried to update our program, and then so that the actual output produced by our program will simply match the expected outcome. So that's scenario number one. So scenario number one happens often, but not as often as scenario two. In scenario one, you're simply given files, but for scenario two, you're given basically a program, which means the responsibility of coming up with new scenarios is up to you. Okay, so that's something we want to see how you can do it. In order to really illustrate this, let me say this. Let me make the following assumption, and this usually these assumptions can be met by your labs or projects for ETF. Okay, again, let me go back to the ETF folder over here. So there are two things I assume you have for your particular lab or projects. Number one, you have a program that reads something like oracle.exe. So it is an executable program. You can think about it's like the solution to the project or the lab. However, we don't give you the source code for the solution. We simply give you some executable, so you can try out the solution for as many input scenario as you can, and then try to improve your current program to match it. Okay, you can think about Oracle, as I said, it's more like a customer who can always give you consultation to confirm if your program is correct. That's the number one thing I assume you have, and make sure you move your oracle.exe file inside your ETF project. Okay, so now this is my ETF project called bank. If you got your ETF project called other things, you should move your Oracle inside into the top level of your project. Number one. Number two, there's also a regression testing script that we actually offer to you, written in Python. But any computer should be able to run Python easily. So that's a regression testing framework we gave to you, and that one has these two files. When you were made available this folder, also make sure you move it into the top level of your projects. Okay, if you really don't have it right now, what you can do is you can simply go to my tutorial pages. You can go to ecs.yahoo.ca, tell.jackie/teaching/tutorials, and then you can see there's a section there called ETF tutorial, and then you can actually download this particular script as a zip folder. You unzip it and move it to the top level of your ETF project. Okay, so these two assumptions, make sure you meet them before you continue with the tutorial video. Okay. One thing I want to illustrate very quickly, okay? Usually, you might simply assume Oracle is an executable program. So, let me just go back to the top level of my projects. Okay, so now you can see I'm still at the top level of my bank ETF projects, you can see I got oracle.exe. Whether you're using Windows or Mac, you would think it's an executable. So maybe I should just be able to say oracle.exe, maybe using the interactive mode -I. However, you will simply say cannot execute binary file. It's simply because usually when we distribute the Oracle file, we only give to you something that's executable on our Linux environments, on any one of the Linux account or Linux machines. So it's not going to be executable on your Windows or Mac. So what can you do right now? You basically have no choice but to really log in remotely into your Prism account and run it there, or just physically go to a Prism machine. However, now I'm going to show you a workflow that's really going to help you on resolving this issue here. And again, the oracle.exe is really some Linux executable that you shouldn't try on your local machine. Okay, number one. Number two, as I said before, every time when you were given a particular new input scenario over here, either AT03 or maybe it's simply something AT04 that I simply want to try out on my program. If I try out AT04, let's say I'm trying to do transfer between two accounts, and then I'm wondering about what the expected outcome should be. In that case, I definitely can just consult with the oracle.exe. And now I want to run it, but the only place I can run it will be on the Linux server. So now how can I streamline the whole process to be as smooth as possible? Okay, so there's another implicit assumption I'm making here, the third assumption. I'm also assuming that you also have checked in your ETF projects into a private repository of Github. Okay, you can also follow along the Github tutorial elsewhere. I also got a tutorial series for that. You can also follow them. So now I'm assuming this too. Okay, so what I will do is let me just show you the process for now. Okay, so now what we want to do is this. Let's say I have currently let me go back to my folder over here so it's easier for me to illustrate. Okay, let me just go back to my ETF project folder over here, and then I want to create a new test basically. Okay, so what I want to do is I'll go to AT03, I will simply copy and paste. Okay, and then I will rename it to AT04. And then I'm gonna add something a little bit new. Okay, so now instead of having, I still have ID1 and ID2, but now I want to just get rid of the withdrawal, let's say, and then I want to say deposit into the account with ID1 and also deposit into the account with ID2. Okay, let's say I want to try some slightly different amount, 200, 200. 200 and 200. Of course, this should be ID2. So now I got two different accounts with the same balance initially. Now I want to try out a different command to test. Let's say I want to transfer from ID1 to ID2. Let's say transfer an amount of 50. Let's say I want to do that. So what I will do is I'll say transfer, and you can look up the grammar to see how you can do the transfer. It will be from ID1 to ID2 with $50. And of course, I will expect to see 200 should go down to 150. And then that $50 go into 200. So it becomes 250. Okay, that's easy to expect. But now apparently we have not done the transfer just yet. And of course, it's not going to pass, right? But now I want to show you how you can streamline the process, okay? Of course, if you still want to do it manually, you have to basically do the following. You have to run your program from ifgens on AT04 and then redirect it into AT04.actual.txt. You are going to do this manually again, and then manually compare AT04.actual.txt against whatever the Oracle can generate, right? You can see that's kind of like a very tedious process over here, right? That's not something we really want to do, but I can just show you one time, okay? I think I just do it one time manually, okay? You should know at least how to do it manually, and you can appreciate why automating the process will be really beneficial, okay? So now what I will do is I'm going to go into our Prism account. So what I will do, I'm using a Mac, so I can simply use a terminal to remotely log in to our server. And if you're using Windows, you can also use a program like a PuTTY, okay? Depending on which program you're using. But as long as you can do SSH, that will just work. So I would say SSH as Jackie, so that's my student account, red.eecs.yorku.ca, and then of course whatever password I have. And now I'm now in my home folder of my student account. I will simply make a directory called 3311, for example, okay? And now I'm gonna say how we can do the scenario number 2. First of all, I'm going to check out my GitHub account, and apparently I already made some changes. Remember, we made changes to ATO3, the actual withdrawal in the account, and etc. So these are the changes I want to push back to my GitHub account. Okay, so I will just say over here, so now I'm on the GitHub desktop of my local machine, right? I want to push them to the cloud first. So when I check them out to my Prism account, it will be the up-to-date version. So changes to support withdraw, for example, and then I'll say commit, and then I'll say push to the cloud. Okay, just make sure everything's done. Okay, so now it's done. So now what I will do is I'll go to my GitHub account. Okay, if you follow along my GitHub tutorial video, you will see this process, or you would have seen this process already. I'll simply go to the clone or download. Okay, and then I can simply just copy this particular link, this URL here. I can click on here to copy. And then I'll go back to my remote login. So now I'm now in the red account, in the Prism account. So I would say, and I'm currently in as Jackie. Good. So now I'll say make directory 3311. Oh, it's already there. Good. 3311. Go into it. It's now simply just empty. So now I would say git clone, and then that URL I just copied, right, from the web browser. And then I'm going to log in, of course. Okay, so my Yorku email, and then of course my password. So now you can see the entire ETF folder is now checked in to my Prism account. So the process I'm going to show you now, there's a principle to this. Okay, let me just show you quickly some diagram. And then, okay, it's actually very easy to understand this. So now this is my home copy over here. Whenever I do any of my developments, I might make some change to support withdrawal, for example. As soon as I'm done, I'm happy with what I have done so far, and then I can simply push and commit, of course, the changes to my GitHub copy. So that's very good for backup, and also keep a version history of my work. And then later on, as I will show you, we can always pull or clone the latest copy for my project into this Prism account, where I can actually, this is the most important reason for doing this in the Prism account, because only in the Prism environments can the Oracle be executable. And then we're going to show you also later how to do regression testing. We'll get there, okay? But at least get this picture straight. Okay, so now I'll go back there. Before I show you how the regression testing actually works, let me just show you the manual one again. Okay, at least you know how to run the Oracle. Okay, so now I'll go to ETF, and then if I go to the ETF projects called bank, okay, you can see that's one of the things I assume. You got the executable called Oracle that's executable in Linux. So if you try the following, Oracle, if you simply try that, okay, even though it's an error, but this error is good. You're saying either you say -I or say -B. Okay. So now what I will want to do is, let me go to, again, the tests folder. Acceptance instructor over here, and now I should see AT04, right? Remember for AT04, it is 04.txt, sorry. AT04 is about doing transfer over here, right? So now what I want to do, first of all, I want to compile my projects. Okay, now so let me just go back. So now I will simply say EC 19.05, or depending on what the current version of your Eiffel Studio is. Right now it's 1905. C compile. Maybe I want to get the optimized version, or actually W code is fine, but it doesn't matter. Okay, so I would say finalize, okay, and then config, and then I would say over here bank.ecf. Okay, while it is compiling, I would like to explain something very fundamental to you. Okay, let me just go back to my iPad, and then while it is compiling, okay, I want to explain this particular flow, this diagram over here for you. Okay, we talk about something called regression testing over here. Regression simply means repetition. Regression actually usually comes from the context where you're trying to do your reading. And people say when you're doing your reading, regression is always a bad idea because you don't want to really read over and over the same line or paragraph again and again and again. It's going to slow you down. However, in software developments, regression testing is actually very, very crucial and beneficial to do. That is to say, every time if I make some particular change to my project, I want to make sure all the existing test cases that used to pass, they still pass. None of them actually fail. If any one of them fails, that means I injected an error into my developments by the new extension. That means I should really change it. Okay. Anyway, so regression testing is good for software developments and for the engineering. So this is the idea. Eventually, you will maintain some repository of regression tests. Okay, repository of test cases. And some of them might be given to you, for example, AT01 to AT03.txt, right? Some very small number might be given to you as maybe 3 pairs of AT01, 3 pairs of the input, and also the expected outputs. Text might be given to you. Okay, so let's say AT01, AT02, all the way to AT99. Okay, so you should really maintain as complete as possible in the repository. So the idea will be as follows. In order to show your program is actually correct, okay, the best we can do is like this. The Oracle program, you can think about, of course, it is an executable, and then it's as if it is your customer. And the Oracle, the reason that it's called Oracle is anytime you want to know what the expected outcome is, consult with the Oracle. Oracle will tell you what the expected outcome should be. Okay, so now given AT01, if you want to know what should be AT01.expected.txt, execute the Oracle program on AT01.txt, in which case it's going to generate AT01.expected.txt. What about AT02.txt? What should be the expected outcome that my program should produce? And run the Oracle program on that, and then you will get AT02.expected.txt, and etc. So eventually you will get these maybe 99 expected outcomes. And of course, once you run the Oracle program on every one of the input test cases, either they were given to you, a very small amount, and the most of them should be your responsibility as a developer to come up with your own test cases. So maybe if only AT01 up to AT02 were given to you, but AT03 all the way to AT99, you should come up with your own. You should be responsible for your own correctness of your coding. Okay, and then the way to do it is you can imagine I need to say mount AT01.expected.txt together with AT01.actual.txt. Of course, each of the actual file is simply produced by running your program from the ifgens on the corresponding input file. Right? You can see the process. If you want to do this whole process manually for 99 test cases, it's quite tedious and you might just make a mistake. And especially, you'll be very annoying as well. If you change your development so often, maybe every hour, in that case, every time if you make any changes, the idea about regression testing is you have to rerun all the 99 scenarios to make sure none of them is now violated. So you can imagine if you want to repeat a manual process every hour for the 99 test cases, you don't really want to do it. Okay. So now what we really want to do is to show you some way to actually automate this process. But at the end of the day, every time you will do the regression testing, you will make sure the entire set of the expected files are equivalent to the actual outputs that's from your program. Okay. Hopefully that's clear to you an idea. I just want to show you one thing just about how you can manually run one test on the server using Oracle. Okay, and then I will get to regression testing. Okay, the compilation is done. So now I do have an ifgens folder on my server. Okay, so now what I will do is I'll go back to the test folder, and then I'll go to acceptance instructor over here, and I have AT03.txt, right? So now what I want to do is I want to figure out, given this particular AT03.expected, right? Given AT03.txt, the input file, what should be the expected file? Run the Oracle program on that, and it will generate AT03.expected.txt, and then I run my program ifgens on AT03.txt, and then it will generate AT03.actual.txt. Compare them and see if they're identical. That's the manual process. I'll do it just once for you. Okay. So let's see how we can do it. Oracle.exe batch mode, and then that's Oracle that's given to you. Okay, and then we'll say AT03.txt. Redirect that to AT03.expected.txt. Oh, sorry, AT04. I beg your pardon. It should be AT04. Let me do it again. Okay, AT04 is the one that you're given. Okay, I just got it wrong. AT04. Okay, AT03 is already resolved in scenario number 1. AT04 and AT04. Okay, so now we got AT04.expected.txt. Okay, this one's done. And then let's try again. So we can say AT04.txt. Okay, that's the expected file. What we want to do is we want to generate the actual file. For that, we need to run the ifgens, right, from our program. Sorry. ifgens bank, and then we'll say w code. Oh, actually, we finalize it, right? So it should be f code. Okay. If you only try to freeze your project, you will go to w code. If you finalize your project, go to f code. Okay. And then bank -b AT04.txt, and then redirect into AT04.actual.txt. You can see what I'm doing now is only for one case, and then diff. Okay, on the Linux server, you can also try melt. If you're using a physical Prism machine, you can also use melt to show the GUI. Okay, diff AT04.actual.txt. That is what's actually produced by your program currently. May not be perfect, may not be correct. And AT04.expected.txt. This is what's produced by the Oracle program. It's guaranteed and assumed to be correct. Okay, if I try that, you're saying that they are not the same. Especially because in the actual output, for the transfer, I didn't do anything. They still remain to be 200. But now the expected outcome should be after the transfer 50. So now the first account should be go down to 150, and second account should go up to 250, right? So there's this discrepancy between the actual output and the expected output. So what should I do? So now what I should do is I should really try to actually change my local developments, and then try to commit, push the changes, and try again. Okay, that's what I should do. So what I would do now is like this. Okay, I want to show you just how you can run the regression testing. Okay, you can see right now we got AT01, AT02, AT03, AT04, right? Let's imagine the following. Okay, so now let's say this. We got all the files over here. I'm now just going to remove all the actual file. And then I'm going to remove also all the expected file. The reason is I got my Oracle. So as long as I can run my Oracle on each one of them, I should be able to generate the expected output. Okay, that's the idea. So now I want to show you how you can use the regression testing script, okay, which will be very handy. Okay, so the idea would be for this particular diagram. So now I have basically AT01 until AT04. Now I want to streamline this particular process to check every one of the 4 actual outputs against their corresponding expected output. Okay, so now what I will do is I'll go to the regression testing folder, which I assume you have, and you already check into your GitHub repository. Okay. Okay, so now what I will do is this folder here is called regression testing over here. Okay, regression testing. And I will simply go into that particular folder, and then when you run the script, you do not modify ETF test Python. You don't do it, you just run it directly. But I'm not gonna do it in just a moment. So what I will do is I need to modify this particular ETF test parameters.py. Okay, so now one editor you can use is Nano. You can use any other editors you like. ETF test parameters.py. Okay, so now the script over there, you will see the root will be where are the tests folder. In that case, you will simply just go to, that's why if you already put your regression testing folder at the top level of your ETF projects, this part will just work. Okay, and then under your tests folder over here, I want to include two subfolders. Okay, one is called acceptance instructor. So all the test cases that go into instructor will actually be run. And also every test case that goes into students will also be run. Okay, for now, of course, the ones in student folder is simply just empty, nothing there just yet. And then, of course, these two lines are simply just commented out, so you don't need to worry about them. So what I want you to pay attention to is the Oracle program is the Oracle you're given. Okay, dot is actually correct. Dot is referring to the top level of your ETF projects, but now you should say Oracle.exe. Okay, you gotta change that appropriately. Okay, and then executable over here is basically how can we run your projects, the current project build, right? So now what I would need to do is I gotta say ifgens, and now in this case, depending on the project name, you'll be bank. And because I simply finalize my project, so I have to say fco over here. But usually, if you're simply just using freeze option. When you compile, you can just use the wco option. Okay, it depends. And the executable name will just be called bank. Okay, and then one more thing to actually to show you, which is very important. So now there's another flag over here. Is called is expected. So when it's expected is simply false, that simply goes like just like the diagram I showed. If the is expected flag is simply false, that means every input file over here will be run by the Oracle program to produce the corresponding expected file. Okay. On the other hand, if you simply set is expected to be just true, what that means is you will simply try to ignore the Oracle over here. That's assuming that you don't have the Oracle available at the moment. In that case, you will simply say whatever you're given, maybe remember AT03, that's exactly the case. When you were actually directly given maybe AT03 and also AT03, the expected file, right? So now I would say since we got Oracle, so you should really change the flag to be false over here, okay? Once you have set this up, okay, so what we'll do is now we're going to run the regression test. Okay, you simply say dot current directory and the ETF test. Okay, or you're running this script directly. Okay, if you say that, it's actually now going to run over AT01, 02, 03, and 04, all the 4 test cases by the Oracle program, produce the expected files first of all, and then run your program on the same set of test cases, and then generate the expected, generate the corresponding actual files, and then compare them one by one. The whole process will be automatic. That's why running the script regularly will be very beneficial. So what I will do is I will simply say run this. Okay, maybe it's not executable. Let's make sure it's executable. ls minus la. Okay, what I will do is, maybe I should really say this. Okay, dot py, like that. Okay, just make sure you spell the name correctly. If I do it, it will simply tell me the file. Try to read it carefully. It's saying that running acceptance test from the file, first of all, is running from the instructor folder and AT01, AT02, AT03, and also AT04. Somehow they also generate whatever that's produced by your particular program from the ifgens into a log folder. And then it's AT03, the actual.txt, right? Remember, we had to run it manually, but now it can be generated automatically. And then you'll also see the expected file in the same in the same log folder. Okay, so now we got 4 different test cases, and then it's showing us 3 out of the 4 passed. Well, which makes sense because the last one involving transfer is not being passed, so we gotta fix it. Okay, we'll do that. Okay, so now you can, and that tells you if you want to see what the discrepancy is for each one of them, you can simply run this particular program on your Prism account. Okay, so now I would suggest you don't necessarily have to go to the melt. As long as you know there's some discrepancy, you can just use diff as well. Melt works the best if you actually got if you're actually in front of a physical machine in the Prism lab. If you're using your home computer using just a normal terminal, it might require some process to set it up for the X terminal, but I wouldn't cover that in this tutorial video. Instead, what I can do is I can simply say diff log acceptance instructor AT04.actual.txt log acceptance instructor AT04.expected.txt. Let's say if I do that, right? So now if I do that, it simply tells me, okay, there is discrepancy, and that's exactly the same thing as we saw previously, right? Okay, so that's just confirmed. But the biggest advantage is we are automating the process for running regression tests. So what I want to do now, I want to basically fix the error for my local machine. So basically, let me show you this. Before I do that, let me just commit everything from my GitHub, okay? Because I made some changes on the server, so make sure everything can be up to date on one side before we do the syncing, okay? So now let me go, where am I? Okay, so now let me just go back here, okay? So now I will simply, let me remove the ifgens is actually ignored from my GitHub account, so it will just ignore, so that's fine. So I can just say git add everything into my add all the changes to my local to the current local repository, and then ifgens is ignored, and then I would say git, and then I would say commit, put some message over here, and then we'll just say tried regression testing for AT04, right? That's what we did. Okay, of course, we're gonna just make sure we just commit. Okay, so these are all the changes we did. Okay, I just confirmed it's actually correct. Okay, and then I'm gonna run a command over here. Okay, let me just remind myself what it should be. Okay, let me just write it down. Git push origin and master, and also I'm including also the log folder. I'll actually show you the log folder in just a moment. Okay, but now I can also push them. Okay, again, my GitHub account. Okay, everything's done. So now let me just show you quickly the log folder. If I go into regression testing over here, and then you can see there is a folder called log over here, right? If I go into log, you can see something called acceptance, and then also instructor. Of course, if you got student test, you also got student test over there. And then you can see this is exactly how you would have done it if you actually run it manually. So for AT01, I got both the actual version and also the expected version. Everything here is automatically generated by the Python grading regression test script. Okay, everything is generated by there. Okay, so these are things that will always be freshly generated when you run a regression test. So of course you may choose to ignore them when you commit to your GitHub. I just chose to include them anyway. That doesn't really matter. Okay, so now I want to show you the final thing I would like to do. I really want to pass all the regression tests, especially AT04. To do that, let me show you again the flow. And remember this thing here? So what I will do now is very quickly, I'm going to modify my home copy over here to fix the transfer, and then push that into GitHub, and then pull that into the Prism lab, and then rerun the regression testing, make sure everything works. Okay, that's basically what I'm going to do. And then I'll make a final conclusion remark, and then we're done. Let me go back to Eiffel Studio on my local machine over here. How do I do transfer? Okay, if I want to do transfer over here, I will simply go to, do the easiest way, right? So if I go to bank over here, and of course, currently the only class that's calling the transfer is called ETF transfer. Okay, let me just copy this signature over here. Okay, I'm gonna fix the call in just a moment. In bank over here, so rather than transfer, it's gonna be something like this, and then just like that, right? I'm gonna do some very inefficient interpretation, but you can definitely improve it later. Okay, so what I will do is I'm gonna say across, okay, and I'm gonna say accounts is ACC1. Okay, I'm gonna do a nest loop. Basically, I'm gonna locate the two accounts. It's very inefficient. I just want to make it work. Of course, you gotta have a better interpretation than mine. Is ACC2. Okay, and then I'm gonna have a nested one. Okay, and then accounts is ACC2. Okay, loop, and then, okay, so now I'm basically getting ACC1 and ACC2, right? I can fix the indentation to be a little bit better, so hopefully that will help you read it better. Okay, basically I'm talking about two accounts, right? So now what should I do? I'm going to say if ACC1.id is the same as ID1 and ACC2.id is the same as ID2. In that case, I want to do transfer. What does transfer really mean? You want to deposit from one and withdraw from another, right? So I would say ACC1.withdraw. Withdraw. And then I was going to say withdraw this particular amount, and then ACC2.deposit. Right, this particular amount. Okay, that's transfer basically. Hopefully, no surprise to you. Okay, let's see why I have this. Maybe I misspelled something. Apparently, yes. Okay, let me be careful. Copy that. Okay, and then compile. Okay, and now the only thing left is about this particular call to the transfer, right? So now I should really say transfer from the ETF transfer class, ID1, ID2, and also the amount. Okay, and then I'm going to say compile over here. Okay, everything compiled. So now I believe things should work. But how should I know? Basically, again, go back to this particular diagram over here. So now what we just achieved was this. We make some changes, but now I'm still not sure whether ATO4.txt together with all the previous ATO1, ATO2, ATO3 are all working. I want to make sure everything is working, right? To do that, I need to run an Oracle on ATO4, generate the expected file, and then run my program on ATO4, generate the corresponding ATO4, and compare these two, right? That's what I should do. And I can only do this on my server, right? Because the Oracle is not directly executable on my home machine. What I should do now is I should go to GitHub. I want to commit. Okay, so now I should say, so now I implemented transfer. And then I'll commit. And then I should push to the cloud. Okay, I should really basically I should update first. Okay, that's what's. Remember, I did some changes on my Prism account, so I need to poll first of all, and then push. Okay, make sure always is up to date. Okay, nothing wrong. So now if I push, okay, everything is pushed. So now, if I now go to, so everything is now up to date. So now you can see I have completed this particular step over here, right? I have committed and pushed all the update to the GitHub cloud. And now I can now pull them into my school copy and then run Oracle and also regression test. Let me do that quickly and really show you the complete process. It's really important for you to master this particular process. Okay, so now, okay, I'm now in the regression test folder, but now I'll just go to the top. Okay, so now if I say git poll, okay, again, I'm gonna log in. Okay, so now basically, so these are the two updates I just did on my local machine, completely making sense. Okay, so now what do I expect to happen? Of course, I could have manually tried to run AT01, AT02, 03, 04, everything manually, but I don't think you want to do that since we got the great regression test script. Go to regression testing, and then nothing I need to touch, nothing, okay? Because now AT04 is already in the tests folder, and the parameters that we set up previously is going to include all the test cases from instructor and students. Okay, so now what I will do is I'm going to run ETF test.py. So now, what I'm just illustrating is something you want to remember as well. So now this, you can see this is still showing one still failing. That's because I did not recompile my project. That's why. Okay, so now again, every time if you update your projects, you want to make sure you recompile your project. Otherwise, the changes will not be included, right? Okay, so many things you want to remember. That's why it's worth having a tutorial video for this. You want to really know the process well. Okay, remember previously I got the F code. Let me just show you something maybe faster. You can do W code. I'll just show you both versions. You can choose either one. Again, EC 1905 and then -C compile, and then I can say freeze. Freeze simply means we don't really generate the optimized C code. We simply just make some incremental fast compilation. Okay, when you are still in the middle of your development, this might be a more preferred option because it's faster. It will save time. Config, and then we'll say bank.ecf. Okay, let's compile that. Okay, while we're waiting for the compilation, I would suggest I do a very quick summary of what we have achieved in this tutorial video and how you should go beyond this. Okay, so now we talk about how you can really try to streamline the process of automatically test your projects as you are adding test cases to your repository. Okay, so now you have GitHub as a backup, and you actually got consistent copies in both the home and also the school. Okay, and every time you make any changes, of course, you can stay with your home machine because maybe you are familiar with the development process for editing, compiling, and also using debugger. Okay, and then for the school copy, that's the biggest advantage is you can run the Oracle executable over there. And also, remember, whenever you submit your lab or project for grading, this is the platform where you're going to run your project for grading. And then you want to make sure that everything actually still works on the Prism Lab environments, right? Just working on your home computer doesn't necessarily mean you will also work on the computer in the school. Okay, that's really another big advantage of running this entire process. And then make sure you really understand this particular process over here. And then now the final remark I would like to say, okay, is for this particular inputs repository over here, that's your acceptance test repository, right? Let me write it down. So this is your repository of test cases, right? I already said it. Okay, you want to really keep adding to this particular repository as often as you can. Every time you can come up with some test cases that you can add them into this test case to this repository, and then as soon as you finish developing for a particular units of extension, you should really test them. Okay, by running the regression test script over to make sure everything still runs. Okay, before you submit your submission for grading, you want to make sure everything still passes. Okay, so now everything compiles. Okay, so now remember we actually use the W code option. We use the freeze option over here. So now the executable will be in the W code. So what I want to do is I will go into regression testing over here. And before I run it, I should really modify ETF test parameters.py. Okay, make sure you now change that. Of course, if you're not familiar with Nano, that's fine. Okay, you can choose any editor you wish. Rather than F code, I'm going to say W code. Okay, and just one more thing to mention. When you are adding your own AT, like AT05 all the way to AT1000, for example, right? So now what you want to do is, since every AT files in the instructor and in the student will be tested, you may just want to keep the ones that we gave to you by default just over here. And then you want to keep yours in the students. Okay, that's what you want to do. Okay, save it, and now it's not gonna retrieve the executable from the W code in the ifgens. So what I will do now is to say ETF test.py. Sorry, type it wrong. No underscore over here. If I run it, you'll see now that's good. Everything just passed. Okay, so I really illustrated the whole entire process for you. You realize your current program is not meeting the expectation. You go ahead and change it, change in the developments in your local machine. Push it back to the GitHub, pull it back to your Prism account, and then run the regression test again. And we see everything passed. Okay, really try to study this tutorial video carefully to understand the benefits of regression testing.